Hi everyone. I'm going to be doing the societal impacts of the May 31st, 2013 Reno, Oklahoma tornado, the widest tornado ever recorded. It was 2.6 miles wide. It was originally an EF5 but downgraded to an EF3 because of the damage survey. Even though it had winds strong enough to be an EF5. It killed 8 people, including 3 storm chasers, unfortunately. And again, it was the largest tornado to ever be sampled by radar. There was also one smaller anticyclonic satellite tornado, and I'll share a paper later on that you can read, which goes over that if you're interested. There was also flash flooding, which we will talk about later, and there was also giant hail, and I will share a paper that talks about that later as well. So lots of severe weather threats, but today we will be focusing on the tornado. But first, pictures of hail. Okay, so first the meteorological setup. This is taken from a paper by Howie Bluestein and colleagues from 2015. So the synoptic setup, there was a strong area of low pressure in the northeastern corner of South Dakota. There was a mid-tropospheric front, so that means that the front is not at the surface, but it's in the middle troposphere, and Oklahoma was on the anticyclonic side, which usually causes warming and sinking, and that's bad for severe weather. However, strong heating throughout the day was able to overcome that, and the storms exploded out anyway. So that's what you call breaking the cap. And then, even though there was a 500 millibar jet streak, and Reno and Oklahoma City weren't in the best position there for rising air, there was another jet streak at 250 millibar where they were in the right entrance region, and that is conducive for divergence aloft and rising motion. So storms formed near the right entrance region of that 250 millibar jet streak, and that jet streak was able to overcome the warming and sinking associated with the 500 millibar jet streak. Okay, then the mesoscale setup. So you start out with a weak stationary front and a small wind shift gradient draped across western Oklahoma from southwest to northeast. You have a dry line in far southwest Oklahoma with weak dew point gradient. The dry line kind of joins together with the cold front and strengthens it because it connects to it on the southern end of the front and warms it on the eastern side, so there's a stronger temperature gradient on either side of the front. Additionally, there's increased convergence and cyclonic shear along the front and ahead of the dry line. And what ends up happening is first thunderstorms form along an area of high equivalent potential temperature or high diurnal heating, or it could have also been the dry line or a combination of both. Then the stationary front moves south finally as a prefrontal wind shift boundary because the temperature gradient remains stationary, but the wind shift actually did migrate to the south, and that could have been due to outflow from storms forming. There was 5,000 joules per kilogram of CAPE, which is absolutely insane. That's all you have to know. Usually 1,500 to 2,000 is considered a lot, but 5,000 is just absolutely insane. And a thin band of 0 SIN, so that means the cap is popped. That's what SIN is. SIN is the cap. When there is 0 SIN, the cap is popped. 50 to 60 knots of shear, which is also insane, and 400 meters squared per second squared of storm relative velocity. That means there's a lot of shear and a lot of rotation in the atmosphere, which is so it's conducive for severe storms and tornadoes. So I just want to talk briefly about the multi-vortex behavior of the tornado. The subvortices, probably as a result of friction, as you go up with height, they lean out. And you'll see this in the picture on the next slide. And they lean in the direction of the azimuthal component of the wind. So basically in the direction of the angular component of the wind. So whatever that angle is, the vortice is going to lean in that direction. And then the other thing you need to know is that there seems to be a variety of spectrum widths for each. Added together creates a ring of high spectrum width, which indicates turbulence and high shear. So there's a lot of turbulence and high shear within these subvortices. And that could be due to a lot of different things. There's a lot of different more micro scale, storm scale processes going on inside these subvortices that we may not see and that we don't know about. And that could lead to the turbulence and the high shear. And different debris types lead to a more complex Doppler spectrum. I'm sorry if my speech is slow. I'm tired. And then if you look at this figure to the right, starting at the top left and finishing at the bottom right, going across and down, you see how the red intersects with the black line. That's the dry line intersecting with the cold front and helping it strengthen. And there are the subvortices in the El Reno tornado. Okay, so here we go. This is the first study that we're going to look at, the spatiotemporal perspective of the El Reno tornado evacuation. So, statistical studies actually show that most people would prefer evacuation in a tornado. That's very scary because that's not what you're supposed to do in the event of a tornado. You're supposed to shelter in place. So heavy travel and limited number of exits can cause travel and traffic jams, which makes the danger factor higher, and this is why sometimes up to 30% of tornado fatalities occur in vehicles alone. And on May 31st, you had a very interesting combination of events. You had the Moore, Oklahoma tornado that occurred 11 days earlier that killed 24 people. It was an EF5, so everyone was on edge because of that, and I'll be covering that quite a bit in this PowerPoint. And the media got on and gave a very unconventional message, saying that you cannot be above ground, you've got to go south, and you've got to go now. So the media basically gave an evacuation order. And if you look to the right, you'll see that traffic jam. So basically the results of this study, to summarize, are that they were looking at traffic flow, and what they realized is that traffic flow actually decreases during a tornado. But you have to remember what the definition of flow is. Flow is the rate at which something is moving past a specific point. So if flow is decreasing, then that means the traffic's not moving, or there's very few cars. But in the instance of El Reno, there was an evacuation, so we assume that the very low traffic flow is a traffic jam, or the cars aren't even moving at all. I mean, the number of cars per hour decreased from 7,133 per hour to 888 per hour during the rush hour at one of the traffic stations near Oklahoma City, and that's very unusual for that city. So it is concluded that an evacuation can take place with lower than normal traffic volume as long as that volume is moving in the direction that is opposite of the tornado, which was the case with El Reno. So I'm going to actually skip this slide because I think we kind of covered that already. Mirren et al. Is a statistical study. It looked at 3 Oklahoma tornadoes, including the El Reno on May 31st, 2013, and its goal was to see in all 3 events what were the factors that influenced people's decisions on whether or not to take a protective action or not. And they found that out of all the factors, they found that the personal factors such as age, gender, marital status, type of area, tornado experience, all of that stuff they found insignificant in the statistical analysis. They only found that proximity to the tornado and number of information sources used influenced whether or not somebody took protective action. So, with proximity to the tornado, that's someone who's within 5 miles of the path, or someone who's outside 5 miles of the path. And what was found here was that for those in the El Reno tornado that were within 5 miles of the path, they were 5.53 times more likely to take protective action than those who were outside 5 miles of the tornado's path. And additionally, with every unit of it adding another information source, your chance of taking a protective action would increase by 1.84. Now, I want to compare this to Moore. If you look at Moore, the proximity to the tornado factor was only 3.57. Well, that's very interesting. Why would it only be 3.57? Why is El Reno's almost twice that? Well, I theorize that it's because people are more on edge, right? That's been the theory here, that anxiety is higher with the El Reno tornado because of the recent experience of Moore. The Moore hadn't happened yet, so when Moore did occur, taking protective action based on the proximity to the tornado was only 3.57. And then another thing is that the factor for information sources for El Reno is surprisingly low, which might feel contradictory, but it's actually not, because what I theorize is that when people were experiencing the El Reno tornado, they did not need that much verification. I think they saw one or two sources and said, "That's it, I'm leaving," because they were nervous. They were nervous that a powerful tornado was coming to Oklahoma City. So it doesn't surprise me that that factor is low like that. I think it's in line with a higher factor for evacuating, and I believe it's also in line with the idea that the El Reno tornado was prompting more anxiety as a result of more taking place 11 days earlier. Okay, so now we're moving on to societal impact number 2, health medical. So Sylvia Palacios et al., 2015. So they performed a robust statistical analysis to see if there was an increase in the number of cardiovascular events after the 3 tornado outbreaks. And basically they found, between pre-tornado, post-tornado, and the control group from the prior year, that there was no statistically significant difference. And they found that it probably occurred that way because of a high degree of tornado preparedness in this area. Since tornadoes occur so frequently, unlike hurricanes, emotional and physical burdens aren't as strong, so cardiovascular events aren't as frequent because of that, because they're used to tornadoes, they're prepared for tornadoes, they know what to do. It's a regular occurrence. And what's interesting about this, though, is that we did have a kind of rare event with the Moore and the El Reno tornadoes occurring together in the same month. Very strong tornadoes. And you would expect more psychosocial and biological damage, and there was still no cardiovascular events after those tornadoes. So there seems to really be no connection to cardiovascular events and tornadoes. So it was concluded that tornado outbreaks did not increase the prevalence of cardiovascular events, in contrast to the effect of hurricanes. Implementation of a healthcare policy change for early treatment and prevention of CVEs after tornadoes does not seem warranted. And for me, I find this a little hard to take, because I feel like it's only generalizable to the state of Oklahoma. It doesn't really take into account states where preparedness for tornadoes may not be as strong. The only bullet from here that so what can we learn from this study? Well, strong, destructive, successive tornadoes can have additive effects on physical and psychosocial damage, but can still not cause physical. Well, I wrote physical there. Yeah, this bullet's kind of contradictory. All right, screw that. If tornadoes occur more frequently and people are impersonal to them, then it's possible, at least in my opinion, that perhaps tornado preparedness and increased tornado education might actually help people feel less stressed out, and this may reduce physical and emotional stress when tornadoes do occur. It's just just a theory though. All right. Still on the second societal impact, Lee and First. This was a systematic review of mental mental health, of impacts of tornadoes on mental health. Sorry, there's a train outside. And it includes Moore, Oklahoma on May 20th. So the results can likely be extrapolated to El Reno. So there's really two main results that concern us here. The first one is that PTSD and trauma seem to be related to almost all tornado events, regardless of what the other mental health problems are. PTSD and trauma always seem to be co-occurring. This was true for the Moore tornado, where surveys were given, and it was determined that anxiety, including people passing tests for the generalized anxiety disorder, was very common after Moore. So that supports our notion that people were on edge when El Reno occurred. And perhaps PTSD played a role as well. But talking about some protective factors here, dispositional optimism, general expectation of good things, self-efficacy, belief and ability to succeed, hope and social support. Those are all things that people use in order to cope with events like tornadoes. That's what this study found. So what can be learned? Well, PTSD and trauma. Tornadoes do have a significant impact on mental health in that way. And it's likely that there probably was a PTSD aspect that was a part of the anxiety following Moore, which probably played a role in the El Reno mass evacuation. Okay. And then really quick, the stockyards on Highway 66 near Oklahoma City were destroyed, which impacts the selling of cattle. And that's not good because this is a very important area for ranchers to sell their cattle. And, we need to sell their cattle because cattle provides beef and dairy for our food supply. So tornadoes can indirectly impact us by messing with our food supply by destroying farms and stockyards. The El Reno tornado also caused extensive crop and property damage in the areas that were impacted. So what can we learn? Well, tornadoes can have an indirect impact on health by destroying farmlands and stockyards, as food production would slow down or would become tainted. Okay, torfs. This is a really complicated thing here, but this is just the fact that there was a flash flood occurring at the same time as a tornado. So I'm going to call these torf events. So just some background. In the case of multi-threat scenarios like this, it's sometimes difficult to know what to tell people about which hazard to take shelter from, because some of the directions are the opposite of each other. So for a tornado, it's go underground, and for a flood, it's go above ground. And then, and I quote, on May 31st, 2013, a torf event in Oklahoma City, Oklahoma, tragically illustrated examples of one of the additional complexities in warning dissemination and risk perception, which further magnified the danger well beyond the meteorological hazard alone. So there you go. The authors specifically talk about El Reno, not for long, but very briefly. Even more surprising is that members of the public didn't really even know about the flash flood threat. And then this is important. Compared to single hazard events, it moreover illustrates how such events can increase the public's vulnerability because of complications affecting their awareness, understanding, sensitivity, and adaptive capacity. And El Reno would be serving as a prime example of this. So awareness, that's just, observing and seeing that there's an event occurring. Understanding is comprehension of that event. Sensitivity is realizing that we have to do something. And adaptive capacity is doing that thing. That's how I define those terms. And then vulnerability is really just tied into the idea of being at risk, of having a certain event occurring in your area at any given time based on these factors. There's actually no accepted definition of vulnerability, if I'm remembering correctly. All right, so general results here. I know that this is not about the meteorology, but I do want to talk about the meteorological environment a little bit. So, the torf environments exhibited conventional characteristics of a low-level tornadic environment. So the environments were kind of the same. But there were slight differences. There were larger precipitable water values, there was more warm air advection, and there was much higher CAPE, suggesting that torf events provide more widespread and intense severe weather. Moister environments and stronger forcing for uplift. So what it's getting at, and I'll get to it in a minute. I'll say this first. And stronger low-level jet, which helps with moisture support. So what is this saying? First off, you cannot separate TOR events from TORF events because TOR events can also be caused by all these things. Flash flooding doesn't always occur with all those things. Sometimes it's just tornadoes. But what it is saying is that torf events typically do not happen when it's a mesoscale environment. It's usually synoptic. That's what it means by stronger forcing for uplift, moisture environments, and the low-level jet, and warm air advection. All of these things are synoptic scale features. So torf events typically don't happen when it's not a synoptic scale event. And if you think about El Reno, it was a very mesoscale event, but at the same time, you had a stationary front, you had a jet streak at 250 millibars, those are synoptic features. So it's not like there weren't any synoptic fronts. The mesoscale part is the outflow boundary and the dry line. But, I guess sometimes both of those can cause torf events, but more commonly it's a synoptic event that will cause the torf event. But discretely, it's very hard to separate them. And you can see here, if you look at the graph on the right, the red line is the torf events. You can always see, even if it's just at the end, at the edge, to all the way to the right, the value is always higher for everything, for cape, for shear, for bulk shear, for precipitable water, and temperature advection is always slightly higher, which does imply synoptic scale ascent and synoptic conditions for those events. Now, going back to Reno, the main thing to take away from this slide was that the focus was on tornadoes, not flooding, even though there was a flash flood watch in place the day before and a flash flood warning issued at 7:15 that night. There were a few tweets about flash flooding, but not that many. The National Weather Service failed to communicate flash flood threat to the media and the emergency management officials. In fact, if you look at that chat, like they show it in the recorded presentation, if you're able to get it, there's no mention of flash flooding at all. So they definitely messed up on that part. Evacuation also increased risk vulnerability of death, injury from flooding, and 12 people died from flash flooding due to sheltering from the tornado. They went into culverts, low-lying culverts. There was a group of 7 and a group of 5, and they all died because they were sheltering from the tornado, and the floodwaters rushed in and they couldn't get out. So what does one do if there's a tornado and a flood? Couldn't tell you. So, by the way, that was our societal impact number 3, risk and vulnerability. The last 2 slides, sorry, I forgot to mention that. Okay, so this is just the 1 in 500 to 1 in 200 year event. So you can see that north of Seminole and Shawnee, that's where they received a 1 in 500 year event flood within 6 hours. And even in Oklahoma City, in 4 hours, they were receiving close to 1 in 100 or 1 in 200 event of flash flooding at the same time as this tornado business was going on. So this was very, very difficult to really keep it going and everything. And then there's just some rainfall amounts. And then for more information on the giant hail from the El Reno storm, you can go find this paper online. It's rapid scan radar observations of an Oklahoma tornadic hailstorm producing giant hail. It goes into great detail about the radar observations and about it talks briefly about the societal threats, but it goes into grave detail about the radar observations. It's a pretty cool paper. Written by Arthur Witt and colleagues in 2018. And then If you want to read more information on anticyclonic tornadoes, including the one in Reno, which is included in this paper, this is written by Howie Bluestein and colleagues back in 2016. This is the only paper of its kind that I'm aware of that actually really goes into grave detail about the anticyclonic tornado. I haven't read it myself, but I'm really looking to do that soon. So I would highly recommend looking into it if you are interested, since there was an anticyclonic tornado that occurred with the El Reno tornado. Okay, that's going to do it for me, folks. All right, take care.